Live Virtual, here we are moving on, flying, fighting, digging, doing whatever is necessary to pass the classes. Unit 8, Application, Systems of Equations. Okay, as we did in the previous lessons, and as you guys realize so far, many word problems could be solved easily by using systems of equations. Alright, let's see problem number 11 now. For each problem, as we did before, you have to define a variable, you have to write a system of equations to model the problem, solve it, and give your answer in a complete sentence. Okay? 11. Brianna is selling tickets to a choral performance. On the first day of ticket sales, she sold 3 senior citizen tickets and one child ticket for a total of $38. Brianna took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. What can we do? Part A. Let's define the variables for the unknown. Okay? So we need to find what? The price of a senior citizen ticket and the price of a child ticket. How about if we let X be the price for a senior and let Y be the price for a child. Are you okay with that? Now, let's start with the first day. The first day, she sold 3 senior citizen tickets and one child ticket for a total of 38. So if I would say the first day, how should we put it? First day ticket cost, or ticket revenue. How can we write it? Well, we know that she sold 3 senior citizen tickets, so we know the price is X. To find how much she got from selling those 3 senior tickets, right? We'll multiply the number of the tickets with the price. To this one, we'll add the revenue from the children's tickets sold, right? And she sold only one child ticket. Well, it will be 1 times the cost of that, which is Y. Together, all this, 3X and Y, the money from selling senior tickets added to the money from selling children tickets for the first day gave her $38. Okay, second day, ticket revenue, or revenue, it doesn't matter, singular or plural. What we have, she sold 3 senior tickets, right? So it'll be 3X plus 2Y, right? And she took home, not home, to the, whatever fund or whatever organization she's doing this for, right? How many dollars? $52. Is it 52 or 62? I think it's 52. I'm kind of covered. 52. Alright? So these are our two equations actually, and we can just put B for this part because we have a system that says 3x plus y equals 38 and 3x plus 2y equals 52. Now we can solve this one by any means, by any method we learned so far. I like the elimination method. And I'm going to subtract the top one from the bottom. First column here, right? 3x minus itself, nothing. 2y minus y gives me y equals 52 minus 38 is what? 8 out of 12. 4, 3 out of 4, right, will be 1. And we know that the cost of a child ticket is $14. Well, let's find the cost for a senior ticket. What should we do with this? Well, I'm going to take this 14 and plug it back into any one of the equations. How about this one? Now that equation becomes 3x plus 2 times y. Y is 14. 2 times 14 equals 52. 2 times 14 is 28, so I have 3x plus 28 equals 52. Take that 28 away from both sides, right? On the left I have only 2x equals 8 out of 12 is what? 4. 2 out of 4 is 2. Divide by 3. You find that your x equals 8. So the cost of a ticket for a senior is $8 and for a child is $14. Is that fair? Well, I think it is. We are done with this problem. Let's try one more. A farmer raises 5 times as many cows as horses. If he has 168 animals, how many cows does he have? Alright, part A. Let C be the number of cows. Let H be the number of horses. Okay. B, what do we know? 5 times as many cows as horses. So the number of cows is 5 times the number of horses. That's your first equation. What else do we know? The cows plus the horses make 168. What should we do next? Well, we can substitute C equal 5 horses into the second one, which gives you what? 5H plus H equal 168. So I know that 6 times H equal 168. So we divide by 6. The number of horses equals 6 goes in 16 2 times. 2 times 6, 12 out of 16, 4. 6 goes in 48, 28 times. How many horses I have? 28. Good. Do we know how many cows we have? Well, sure we can find. If not, the number of cows will be 5 times the number of horses. 5 times 28, that gives me what? 5 times 8 will be 40, right? 5 times 2, 10 plus 2, 120 cows. And here we are. How many cows? 120. How many horses? 28. You should check. Is it 28 times 5, 120? Yes. Is it 28 plus 120, 168? Yes, it is. We're good. One more problem. Collection of quarters and nickels is worth $3.70. There are 22 coins in all. How many of each coins are there? Part A. Okay. Let C number, equals not number. C equals the number of, actually we should use Q, right? Number of quarters, and let N the number of nickels. If you want to use X and Y, you'll find. What do we know? Well, I know that the number of quarters plus the number of nickels is 22. What else do we know? Together they make $3.70, right? Well, how much money we have in the Q quarters, right? In Q quarters I will have $0.25 a quarter is 25 cents, multiply by the number of quarters. To this one, I will add the value in dollars of the nickels, right? The nickel is 5 cents, which is $0.05, right? Times how many I have. And that should give me a total of 370 cents, but $3.70. Okay? And here are your equations. Now the second one, we should have wrote that into cents, not dollars, but it doesn't matter. I can multiply it by 100. Now I have q plus n equals 22. In the second one, I have 25q plus 5n equals 370. I'm going to use elimination. I will try to make the n's coefficient the same, which means multiply the top one by 5. Your system of equations now will be what? 5 times q is 5q plus 5n equals 110, right? The bottom one stays the same, 25q plus 5n equals 370. I will subtract the top one from the bottom. This way my 5n and 5n will cancel out, right? 5q out of 25q will be 20q. These two eliminate, right? Equals 110 out of 370 will be 260. Okay? Now I'll divide both sides by 20. And I have 20 divided by 20, which is 1. The number of quarters will be 13. If I know I have 13 quarters, how many nickels I have? Well, 22 minus 13, which gives me a number of nickels. Oh, how many? 9. Can we check? Should we check? You multiply 13 times 25, right? And then 5 times 9, you add them up, you should get $3.70. If you don't believe, let's see. 13 times 25, 5 times 3, 15, 5 times 1, 5 plus 1, 6, 2 times 3, 6, 2 times 1, 2, 5, 2, 3, right? This is actually $3.25. Now 9 nickels times 5 cents gives me 45 cents, right? 45, because I'm changing this in dollars, plus 45, 0, 7, $3.70. We're good. We solved the problem right.